Hello everyone, let's do question 1-1. Before we simplify this expression, let's just discuss the key concepts. The concepts that you have to remember when dealing with these exponential functions are the following. Remember that when raising a power to a power, what do? We multiply the exponents. When raising a power to a power, we multiply the exponents. We're raising x to the power a to the power b, so we multiply the exponents, becomes a times b, and then becomes x to the power ab. Right, an example would be maybe 3 squared to the power 3. This becomes 3 to the power 2 times 3, which is 6. Remember that we're going to apply this in this question. And then the other one, when multiplying powers with the same base, what do? We add the exponents. When multiplying powers with the same base, we add the exponents. Let's say we have x to the power a times x to the power b. This is equal to x to the power a plus b. So when multiplying powers with the same base, so this is power, the base is x here, the base is x here. You keep the base, don't change the base, just add the exponents. Like if you have 5 to the power 3 times 5 to the power 4, we keep the exponent, we don't change it, so it becomes 5 to the power 3 plus 4, which is 7. And then another one, you have to remember that any base to the power of 0 is equal to 1. Any base to the power of 0 is equal to 1. So x to the power 0 is equal to 1. It could be anything, even 1000 to the power 0 is equal to 1. And then the other concept you have to remember is the distributive law. The distributive law, right? When multiplying a binomial by a monomial, the monomial multiplies every term in the binomial. What do I mean by that? So if say we have a and then x plus y, this monomial will multiply the x, will also multiply the y. So it becomes a times x plus a times y. It's a negative 2, and then we have x minus 3, right? So we're going to say negative 2 times x. Negative 2 times positive x will give you negative 2x. And then negative 2 times negative 3 will give you positive 6. That's the distributive law. So these are the concepts we have to remember when dealing with question 111. Now let's look at our question. We have b to the power 3 and then to the power a plus c. Do you see that we're raising a power to a power here? So we have to use that, and then times b to the power 3 and then to the power negative a minus c. Again, we're raising a power to a power here. So it means we have to multiply. We have to multiply the exponents. We have to multiply this, multiply that. Please be careful when I'm multiplying this. The common mistake here is that people just multiply the 3 with the a. We're distributing this 3. So it's 3 times a and then 3 times c. 3 times negative a, 3 times negative c. Okay, so it's b, 3 times a is 3a, 3 times c, that is 3c. Then times b to the power 3 times negative a, negative 3a, then 3 times negative c, negative 3c. Okay, now we are multiplying powers with the same base. We're doing this point now. We're multiplying powers with the same base. So we add the exponents. So it's going to be b, then 3a plus c, 3c, 3a plus 3c, plus negative 3a minus 3c, which becomes, let's simplify this, 3a plus 3c, then positive and negative will remain with negative, positive and negative will remain with negative. Let's collect the like terms. Let's collect the like terms in the exponent there. B is equal to 3a minus 3a, and then plus 3c minus 3c. addition is commutative. We can rearrange the terms. And then 3a minus 3a is 0, 3c minus 3c is 0. So we have b to the power 0. And then what did we say about this? Say that any base raised to the power of 0 is equal to 1. So we have 1 as our final answer.